Welcome back. So let's do a confidence interval for this same set of data. We want to construct a 98% confidence interval for the difference in the mean number of bacteria for carpeted rooms versus uncarpeted rooms. So in other words, we want to estimate mu1 minus mu2. Okay, so we've already performed a hypothesis test that indicates that mu1 is, we can be confident that mu1 is bigger. Now we're going to give an actual estimate for the size of the difference. So 98% confidence implies alpha is 2%, 100% minus 98%. Of course, we need alpha in decimal form, so 0.02. And then what we actually need for our margin of error formula is alpha over 2. So, well, if alpha is 0.02, alpha over 2 is 0.01. And then in that margin of error formula, I need to know t sub alpha over 2. Okay, so t sub alpha over 2, which we just said was t sub 0.01. Our t distribution, again, is the one with 7 degrees of freedom. This time, I'm not looking up a t-value and finding the area that goes with it. Remember, t sub 0.01 means you know the area is 0.01, and you want the t-value that gives you that amount of area. Well, if you go over to the table and look that up, you should get 2.998. And then plugging into our margin of error formula, margin of error for this context, that was on a different page, so let's write it down. T sub alpha over 2 times the square root of S1 squared over N1 plus S2 squared over N2. So we have 2.998 for our T, and then 2.677 squared over 8 plus 3.21 squared over 8. And by the way, even though you're doing this on a calculator, on a test, you should always write this down, because if you hit the wrong button and your answer comes out wrong just because you hit the wrong button, I won't be able to give you credit for plugging correctly into the formula if I can't see it on your paper. So conversely, if I see this on your paper, even if you hit a button wrong and the answer comes out wrong, I'm going to, that's not going to be as important to me as seeing that you knew which formula to use and how to plug into it. And I mentioned that because on the last test, some people just put answers down, and I had nothing to give them credit for if the answer was incorrect. Okay, so I was talking a lot there. What do I want to do? I want to get a number here. So 4.43 is what I got from my calculator for that. So then, again, the way the confidence interval works is the lower bound for the interval is going to be your point estimate. So x1 bar minus x2 bar, that's our point estimate for mu1 minus mu2. I want to subtract the margin of error to get the lower bound. So let's see, x1 bar was 11.2, x2 bar is 9.79, and our margin of error is 4.43. So do the arithmetic there, and you get negative 3.02. The upper bound is your point estimate plus the margin of error. So 11.2 minus 9.79 plus 4.43. And we get 5.84. So what we're saying again is that with 98% confidence, we can say that the difference between the population means, the average bacterial level of carpeted rooms minus the average level of bacteria of uncarpeted rooms is between -3.02 and 5.84. Okay, so thanks for hanging with me through this kind of long example, and I will see you in the next video.